Hi guys, in this video we're going to be looking at the representation of data and really it's probably a repeat of what you did last year in year 11, so I just want to run through that quite quickly. And again, when you start doing this in the textbook, if you already know how to do this stuff, you don't need to do it. It's just a matter of making sure that you do know how to do the process for that. So the first way is, if we get a whole heap of data like that, it's not that useful to actually look at that data. It's not very helpful for us. So what we want to do is represent that in a way that we can do something with the data. So the first thing we might do is put that into a frequency table. Alright, so if you're looking at a frequency table, you will set up some intervals. Alright, so obviously we're making the interval there 10, so between 30 and 39. So you just go through your data and you'd probably do a tally with that. And then after you've done your tally, you add up all the values and you'd say there are 4 values that lie between 30 and 39, and there are 12 values that lie between 40 and 49, and so on and so on. There are 56 values inside the tally. Alright, so the other thing, a way of representing that, I mean, you could just represent the frequency if you wanted to, but you could also do that as a percent relative frequency. Now the value about doing that is it gives you a percentage. Alright, so obviously 0.071 would be 7.1% of the data lies in this range. 0.214 would be 21.4% of the data. So it takes into account that, you know, if I give 12 out of 56 might be a fair portion of the data. But if I had 12 out of 560, then that would be a very small percentage. Alright, so it takes away that the need to know how many bits of data there are. Alright, so relative percentage is a really good way of representing that information. Now, if we start looking at doing this in terms of doing your histogram, right, then that's what it would look like. So you have your intervals 30 to 40, 50, 60. Okay, so you're looking at that data there. And you can then start looking at the distribution here. Because that's sort of the data is more towards a negative area there, we know that's actually positively skewed. And we'll talk about that at the end. Right? So it's a nice way of representing your data. You get a bit of a snapshot of you know, what it might look like. Right? So I think it's really good. Right, the second way that you might represent your data is in terms of, probably don't use a dot plot very much, but the stem and leaf plot's quite popular. And the good thing about the stem and leaf plot is that you see all the data and you get the representation, you get the shape. You can sort of see that shape there is similar to the sort of shape that you might get from a histogram. Right? So not only do you get the shape, but you actually get the data values, right, which I think is really, really important. So the way we set this up, obviously 0 to 9, that would be 10 to 20, or 19. So this value here represents 7. That represents 1 and 3, so that's 13, 16, 20, 22, 23 and so on. Now, also from this data here, if you know how many bits of data there are, you can easily work out what the median value is, the middle value from that. So all you have to do is you have to go to the middle value. So you just add them up, right? So let's say there's 20 pieces of data, right? So you might have to go the value that's between the 10th value and the 11th value, right? So you get halfway between that to get your median value. Now, the thing about technology is that will do that for you. So another way of representing this sort of data would be to put this into a box and whisker plot, and that's a very popular way of doing that. And I would highly recommend that you make sure you know how to do this, because I certainly will be asking that sort of question in your test, and I know there's always one of these in your exam as well. Alright, so with the box and whisker plot, it's a matter of just putting it into your calculator, or I actually do have a one that's up for Excel, so I'll just show you this one here. Right, so this one here, it's actually on the network for you to use, and all you do is you put your data in there and it actually does all that for you. With that particular data set, as I could print screen that and put that into my investigation. So that's a really nice way of actually summarising your information into that. Alright, let's go back to that. So box and whisker plot you would do on your calculator. It's a good way of comparing two data sets as well, so you can have multiple data sets next to each other, and then you can talk about whether a claim is true or a claim is not true. Just note some information about that. So your rectangular boxes, each of these sections here counts for 25% of your data. So this box here in the middle counts for 50% of your middle of your data set. So that's 50% of your data lies in there. This middle value is your median value. Alright, so that's a good representation. Now we'll talk about the mean and median in a second, but that's pretty well a really good way of representing it. Now, we quite often have referred to this in the past as the 5-number summary. So the 5-number summary is looking at the minimum value, the lower quartile or Q1, the median value, right, the upper quartile, which we call Q3, the maximum value. Alright, so that's called the 5-number summary. The other thing that we quite often we talk about is the range of the data. So this data here ranges from 3 to 9. And that's sometimes important to do that. Now, if you pick the box and whisker plot that has outliers as well, you might actually have a dot here or a dot out there, and that would be an extreme value. Now, these extreme values are ones that sit outside 3 standard deviations. All right, so and they can affect your data. So again, as I've talked about in another video, you need to consider whether you keep that bit of data in there or not, and the decision made about that is dependent on if it is a valid piece of data. Alright, so if we were looking at the masses of all people in the class, right, and they all hopped on a set of scales, then every bit of that data would have to be included in the data set. But you might have a person who is morbidly obese and maybe weighed 20 stone, then that's going to obviously change that data set a bit. They're going to sit out here compared to most people. So, but because it's a valid piece of data, you'd need to include that. But if you're doing an experiment where you've got a value that you knew was probably from an incorrect measurement, then that would be a valid reason to actually take that bit of data out. All right, so you need to be thinking about that and making smart decisions about that. Now, the key thing that we'd like to do with all this data, and the reason why we present it that way, is so we can look at 2 terms. The first one is the mean value, alright, so this value here, and the other one is the median value. Alright, so we want to be able to look at those 2 values, and there are some advantages of both of these things here. So the mean is obviously your average, alright? And the main thing is it's the most common thing that we'll use. And when we start talking about the normal distribution stuff, right, we always use our mean value, right, for our data set. And what happens there is most times you have your data which is basically like a bell-shaped curve, right? It's called a normal distribution, and so the mean value is in fact the middle value of that data set. All right, so the only problem with the mean value is it can be affected by an extreme value. So again, if we talked about the really morbidly obese person, they might increase the average or the mean of the class mass by 2 or 3 kilograms, because they can add 2 or 3 kilograms to every person. Right, so you get a distorted data set there. So in that case, when you've got extreme values, your median value would be the one that you'd probably want to use. Right, so the median main advantage is that it's easily calculated. It's the middle of the data set. It's not affected by extreme values. Right, so if you've got extreme values, then you'd probably have a better representation of the data by using your median value. So what we're saying there, the mean and the median, they're supposed to represent the average person or the average data value in that thing. So most of the time when we're doing a lot of our calculations, we'll be using the mean, but you need to understand that sometimes the median value and the mean might be the same, and they can simply be interchanged, I suppose, but you make that decision based on the data set that you do have and what it looks like. Alright, so again, if you've got extreme values in there, the median value is probably a good representation of that. Now, The other last thing I want to talk about here is in fact skewness. Right, so your data can, like typically we want to have a bell-shaped curve, right, where it's symmetric about the mean value. Right, so if your data is skewed, what we'll find is that if your mean is greater than your median value, right, you'll find that the data has a tail towards a positive direction. Okay, so if it's got a tail towards a positive direction, then we say it's positively skewed. Alright, or another way of thinking that is much of your data is at the negative end, okay, then it's positively skewed. So you have to think of the negative there. Again, if it tails towards a negative direction, then we say it's negatively skewed, right, data. Or, again, if you want to think about the opposite, if most of your data is at the positive end, then we call that negatively skewed, the opposite process there. Again, I'll just go through the calculator stuff. If I've got a data set, so if you go into your calculator and you've got a data set there, I've got some data here which is, I don't even know what it is, doesn't really matter. So if I've got, say, this data here, number L1, I just want to find the average of that or the median value of that. I will go to my stat button, go to calculate, I can do my one variable stat, just change that to list number 1, enter. Right, we'll just go down and calculate. What it does there, it will work out my mean value, which is my X bar. Alright, it tells me that all my values add up to that value there. I've got my sample standard deviation there for 14.0 there. In my data set, I've got 39 values. Right. I've got my minimum value there. I've got my Q1 value. Got my median value. Got my Q3. Got my max value. All right. So I don't really have to calculate those. I've got a calculator that will do that for me, which is really fantastic. Then with that data set, I can go onto there very quickly. If I go to looking at my histogram, I can change my data set to L1, enter. If I go to my zoom, sorry, you got to quit out of there. Go to my zoom and go F9 or number 9, which is zoom fit. It will give me my best data set there. So it's got 1, 2, 3, 4, 5, 6, 7. So 6 or 7 columns is really what you want there. I can press my trace button, scroll across, it tells me what I've got there, it tells me my range and my data. Alright, if I want to, I can then go and change my data set, so I can have my min value starting at say 70, my max going to 145, 140, and then I can make my scales there. I can make them 10s or I can make them 5s. Alright, so you get the idea. When I graph that, I'm going to get a slightly different graph now, so you can play around with that when you're doing that. The other style of graph that you can get, going back into your stat plot, is you can do your box and whisker. You can either do one with outliers and one without outliers, depending on what you want to do. I generally tend to go one with the outliers, so I know if it has any. And then I go quit out of there. And then I go zoom. So zoom 9, and that will give me my box and whisker plot. You can see I don't have any outliers there. Press my trace button. I can quickly get my 5-number summary there. Okay, my Q1, my median value, my Q3. Alright, so a lot of this stuff that you have to do is really easy to do using technology, and it's not that hard. Alright, so good luck with those questions that you need to do. Remember, when you go through this, a lot of this stuff you've already done before, so you have my permission just to make sure that you are comfortable doing it, and if you want to skip through a lot of those questions, then that would be great. Alright, catch me in class if you need some help, and I'll talk to you soon.